Hello everybody, and welcome back to Biosc140 Human Physiology. This video is going to be for math and other concepts from Laboratory 1. So let's start off. These are the concepts. These are the things that you need to get out of Laboratory 1. There are some things in the supplement, in the lab book, that are not going to be on the exam, that are not important. This slide right here tells you exactly what is fair game for our quiz, exactly what I want you to learn from Lab 1. Lab 1 is designed to be reviewed. It's designed to let you know what stuff you should still remember from past classes and to give you a chance to brush up on what you need to brush up on to be ready for the rest of the semester. So, first thing you need to be ready for. Terms, about 100 anatomical things like sagittal plane, coronal plane, and actual anatomy, so that all the different bones, all the different organs. You need to know all of the anatomy on page 7. From here on out, I will assume you know all the anatomy from page 7. On page 8 and 9, there's a section called data analysis. You need to be comfortable calculating average or mean. Hello, everybody. This is Molly. This is Molly. She's interrupting me. All right, Molly, go play with Moose. All right. Under the data analysis section, you need to be comfortable calculating the mean of a data set. I will assume you know how to calculate the mean once you've completed this lab. So mean meaning average. Next up, measurements and conversions. So on page 15 and 16, there are some practice equations, some practice problems. You need to be able to convert from inches to centimeters, from centimeters to inches. You need to be able to convert from pounds to kilograms and kilograms to pounds. You need to be able to convert from Fahrenheit to Celsius and Celsius to Fahrenheit. I've got some good news for you. I've got some good news for you and some not so good news for you. On lab exams, on lab quizzes, the equations that you need will be provided for you in the question. I'm going to repeat that. On lab quizzes, the equations that you need will be provided. So the conversions will be provided. On lecture exams, they will not be. On lecture exams, the 100-point lecture exams, the conversions, the formulas you need will not be provided within the question, only laboratory quizzes. So be comfortable using those. We're going to go over a question and a weight question in these slides. We will not go over a temperature question in these slides, but there are examples on page 15 and 16. Also on 15 and 16, it goes over how to go from like meter to centimeter, centimeter to meter, milligram to gram, gram to kilogram. You need to be comfortable moving within the metric system. You need to be comfortable moving within the metric system. And then on the section problems to solve, you need to be comfortable solving problems 1, 2, and 3. You need to be comfortable solving problems 1, 2, and 3 on page 16 and 17. And we're going to go over those in this lecture right now. So, as you look through the lab, you're going to notice there's some things in the lab that are not listed here, like calculating molarity, calculating a percent solution. You should be familiar with that stuff. You should have done that stuff in previous classes. But It's not fair game for the quizzes because we're not going to use that math later on in the course. The stuff that's listed on this slide right here, we will use later on in this course. And because of that, it's fair game for Lab Quiz 1. Be ready, practice. What I recommend you do now is you pause the video and you go and do these problems, look over these sections in Lab 1, and then come back to this, and I'm going to go over a couple of these problems, these math problems for you, or with you. So a good way to practice conversions is to take your height in inches and convert your height in inches to centimeters. Expect to get one of these questions on a checkup and on a lab quiz. You can also do it for your weight. So here are the equations, or here are the conversion rates. 1 centimeter is equal to 0.39 inches. 1 inch is equal to 2.54 centimeters. Think about this logically. So this isn't my favorite way to memorize this, but some students find this tip helpful. You look better in the metric system. So what does that mean? It's a way to logically think about the answer you've come up with when doing one of these conversions. So most people want to weigh less. A lot of people want to weigh less. Well, a kilogram is larger than a pound, so you're going to weigh fewer kilograms. So if you're going from pounds to kilograms, and the number of kilograms that you have is larger than the number of pounds you started with, it just doesn't logically make sense. You probably did your math wrong. So once again, when you do these problems on the quiz, on the test, come up with your answer and then think about it logically. If you're converting pounds into kilograms, you should have fewer kilograms than pounds, because a pound is smaller than a kilogram. So if you start off with 10 pounds and you do your math and you have more than 10 kilograms as what 10 pounds is equal to, it just doesn't make logical sense. So go back and check your math. That's what this phrase is getting at. So let's look at this. So if you weigh 120 pounds and you're 66 inches tall, you can convert those to the metric system using this math right here. So we've got 120 pounds, that's what how much you weigh. Imagine a line underneath this with an imaginary 1 below it, and that might help you set up this, this equation. So 120 over 1 times, now you want to get your pounds to cross out, because we're going to kilograms, right? So 120 pounds, imaginary line over 1, times 1 kilogram over 2.24 pounds. That's the conversion ratio right up here, is equal to 54.5 kilograms. You can also do it a different way by using the other conversion ratio that we have, 1 pound is equal to 0.54 kilograms, by setting it up as 120 pounds times line imaginary 1 times 0.454 kilograms over 1 pound. This is still going to get your pounds to cross out and leave you with kilograms. Sorry, this should be kilograms right here. We're going to kilograms. 54.5 kilograms. And then we have this very similar setup for inches to centimeters. Remember how I said you should have fewer kilograms than pounds when you're going from pounds to kilograms? You can think about this logically. It makes logical sense. Here it is for inches to centimeters. Centimeters are smaller than inches, so you should have more centimeters than you have inches. Makes logical sense. 66 inches to 167 centimeters. This next problem is a ratio. Be ready for this level of algebra in this class. Be ready for ratios similar to this in this class. So let's read the question. At rest, a typical left ventricle of the heart pumps 5 liters of blood per minute. Blood flow to the kidneys is approximately 120 milliliters per minute at rest. Assuming constant proportionality, that's a big assumption, a big line right there, pay attention to it. What will be the blood flow to the kidneys if the heart pumps 6.5 liters per minute? So first step, I see different types of units here. So the first thing you should do is get everything in the same unit. So convert either 120 milliliters to liters or 5 liters and 6.5 liters to milliliters. For this example, I'm going to convert the milliliters to liters. So going down to the next slide, we're going to convert 120 milliliters into liters. So now we've got all 3 of our variables in liters, and we've got our unknown x. So let's set up our equation. So it's a proportion. So for every 1.2 liters of blood that goes to the kidney, the heart pumps 5 liters of blood. For every 1.2 liters of blood that goes to the kidneys, the heart pumps 5 liters of blood. So 1.2 over 5 is equal to constant proportionality, x, which is the number, the amount of blood going to the kidneys, over every 6.5 liters of blood that the heart pumps. So let's do some algebra and get x alone. We've got x is equal to 1.2 times 6.5 divided by 5. How do we do that? We multiply both sides by 6.5. Algebra right there. We come up with 1.56 liters per minute of blood going to the kidneys when the heart pumps 6.5 liters of blood per minute. Going down, an electrocardiogram is recording on a millimeter grid paper. So let's go back a moment. An electrocardiogram. So we've all seen these in movies. We're going to actually do these in class. We're going to learn all about them. But we're all familiar with an electrocardiogram from pop culture. This is the thing next when you see a movie and there's somebody in a hospital bed, and you see this screen next to the bed, and on the screen it's going like a line's going across, and it goes beep, and you see the line kind of go up and down and back, beep, beep, and then when the person, when their heart stops beating, it goes beep, 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 and the line goes flat. That's the electrocardiogram. Let's break the word down. Electro, electric, cardio means heart, gram is like a graph. So it's an electrical heart graph. And usually that line that goes beep, beep, it's on a grid paper where the squares are millimeter squares. So 1 millimeter up, 1 millimeter over. And that's what this is talking about. Millimeter grid paper, where the grids are 1 millimeter boxes. So it's moving at a speed of 25 boxes or 25 millimeters per second. So for every second, that line that's going across, crosses over 25 millimeters of graph, 25 boxes, 25 1 millimeter boxes. If the distance between cycles is recorded as 21.4 millimeters, so that means between heart cycles, so between heartbeats, so every 21.4 millimeters, you get a heartbeat. So that line's flat for 21.4 millimeters and goes beep, and you see the heartbeat on the electrocardiogram. Then 21.4 millimeters go, and then beep on the electrocardiogram. What is the subject's heart rate in beats per minute? So this is a very similar problem to our last one, actually. We're going to be setting up ratios. The best way to start out, though, is to write down what we know. So what do we know? We know that for every 1 second, there's 25 millimeters that pass. We know that there's 60 seconds in 1 minute. We want to get to beats per minute. So 60 seconds from 1 minute. We know that for every 1 heartbeat, there's 21.4 millimeters of time between the beats. So let's set this up. The way I would set it up is I'd start off with my 25 millimeters over 1 second. I would times that by 1 beat over 21.4 millimeters. That way we get our millimeters to cross out. Remember, we want to end up with beats per minute. There's no millimeters in there, so we're going to set it up so we can cross out our millimeters. We're left in with seconds and beats. We need to convert our seconds to minutes then. So we're going to add in our 60 seconds over 1 minute. Punch that into our calculator, we get 70 beats per minute. This person's heart rate is 70 beats per minute. Again, you know, this is the algebra ratios where you have the 25 millimeters over 1 second. You need to get rid of your millimeters, so 1 beat over 25 millimeters. You can cross out your millimeters. You need to convert seconds to minutes. You know, think logically through these problems and set them up so you can cross out the terms that you don't like, that you don't want, and you can maintain the terms that you do want, and you can get through these problems. You can figure out how to set them up correctly. Next up, we're going to be doing this in class also. Determine the percentages of each type of white blood cell. So, white blood cells, you might have heard of them. There's lots of different types of white blood cells. We're going to be looking at 5 main types in this class: neutrophils, eosinophils, basophils, lymphocytes, and monocytes. This question is asking you to find the percentage, whoa Moose, the percentage that each type of white blood cell is of the whole. So this is actually done every single day really commonly in just normal blood analysis in labs. This is applicable to the real world. And we're going to get into exactly what it all means when these ratios change and all that when we talk about white blood cells. But you know, this is something that I had done a month ago. So what percentage of your white blood cells are neutrophils? What percentage of your white blood cells are eosinophils, and so on? So how do we calculate this? Well, the problem gives you the number of neutrophils counted, the number of eosinophils counted, the number of basophils counted, the number of lymphocytes counted, the number of monocytes counted. Well, you're calculating a percentage of the whole. So you need to figure out what is the whole first. So add up all the total number of each of the white blood cells. So 92 plus 4 plus 2 plus 36 plus 9, that gives you 143. So now that you know the whole, you can divide 92 by the whole, 143, times 100 to get your percentage, 64.3% for neutrophils. You can double check your work. You add it all up, should equal 100%. All right, if you have any questions, please email me, please contact me. Once again, I'm going to go back to the main points that I want you to get out of Lab 1. Review anatomy, page 7. I'm going to assume you know all that anatomy and all those anatomical terms like sagittal plane. Data analysis, you should be able to calculate the average of a data set, the mean of a data set. Measurements and measurement conversions, you should be comfortable with the metric unit going from centimeters to meters to kilometers and such. You should be comfortable when giving a conversion factor going from centimeters to millimeters, when giving even going from Fahrenheit to Celsius, and you should be comfortable solving problems 1, 2, and 3. If you are comfortable with all that math, you will be comfortable with the math on Lab Quiz 1, and you will be comfortable with all the math and anatomy for this whole semester. Once again, if you have any questions, reach out to me. Have a fantastic day, everybody.